Section 2.4, Zero and Negative Exponents. In this section, we will simplify exponential expressions with a zero exponent. We will rewrite negative exponents as positive exponents. We'll review the properties of integer exponents, and we'll simplify exponential expressions using the properties of integer exponents that we've been learning. For any number a, and a cannot equal 0, we know that a divided by a is equal to 1. We know that if we have a number divided by itself is equal to 1. This property is true for exponential expressions as well. For example, for x not equal to 0, we know that x to the fourth divided by x to the fourth is equal to 1. We also know that this expression can be simplified by using the rule for dividing exponential expressions with the same base. We know that if we have x to the fourth divided by x to the fourth, since our base x is the same, we can subtract our exponents. So x to the 4 minus 4 equals x to the 0. So since x to the fourth divided by x to the fourth is equal to 1, and x to the fourth divided by x to the fourth is equal to x to the 0, that must mean that x to the 0 is equal to 1. That's a 0 right there. So what this is telling us is that if we have an expression raised to the 0 power, it must be equal to 1. Now notice the expression 0 raised to the 0 power is not defined. Look at the two examples on this slide. We have 12a cubed. Notice that's in parentheses and it's all being raised to the 0 power. So based on what we've just learned, this must be equal to 1. Now in the example below, we have the opposite of y to the fourth raised to the 0 power. So this is like multiplying negative 1 times y to the fourth raised to the 0 power. So this would be equal to negative 1 times 1, which equals negative 1. 5 raised to the 0 power equals 1. Negative 5 raised to the 0 power is also equal to 1. Now notice here the exponent 0 in example C is only on the x. So this is saying negative 5 times x to the 0 power, which is negative 5 times 1, or multiplied by 1, which equals negative 5. In example D, though, notice the negative 5 as well as the x, it's all being raised to the 0 power, so this will be equal to 1. Negative 36 raised to the 0 power will equal positive 1. It's all within the parentheses, all being raised to the 0 power. However, in F we have a negative 1 times 36 to the 0 power. So this equals negative 1 times 1, or multiplied by 1, which will equal negative 1. 14y squared, all being raised to the 0 power, will equal positive 1. In H, negative 14y squared, all being raised to the 0 power, will also equal positive 1. Notice these examples all look very close together. We have 3/4 raised to the 0 power. This will equal 1. In J, we have a negative 1 times 3/4 being raised to the 0 power. So this is negative 1 multiplied by 1, which will give us negative 1. In K, we have negative 3/4 multiplied by x to the 0 power. This is negative 3/4 multiplied by 1, which equals negative 3/4. Now here I've inserted a blank slide because I'm going to start talking about negative exponents, and I believe this will help you understand it a little bit better and then it'll be summed up on the next page. So now we're going to learn how to deal with negative exponents. So if we're writing answers in scientific notation, we're going to have negative exponents. But in this section, when we simplify our expressions, we want to make sure that our answers are written without negative exponents. So let me just give you a problem that you'll be able to answer or to simplify. So if I tell you to simplify x squared over x to the fifth, that's the same as saying x squared divided by x to the fifth. And we know that when we have like bases, we can subtract our exponents. So this will equal x to the 2 minus 5, which will give us x to the negative third. Now let's simplify this same expression by expanding our expressions. We know x squared, I'll just write it, we have x squared over x to the fifth. So on our numerator we have x times x. And on our denominator we have x times x multiplied by x multiplied by x multiplied by x. We know that x divided by x is 1. We know that x divided by x is 1. 1 times 1 is 1. And on the bottom we have x times x times x, which is x to the third. So we know that x squared divided by x to the fifth is x to the negative third. We also know that x squared divided by x to the fifth is 1 over x cubed. So this must mean that x to the negative third power is equal to 1 over x cubed. So x to the negative third equals 1 over x cubed. So this will explain how, help us understand how we can make answers with negative exponents, rewrite them so that they have positive exponents. What you're going to do is you're going to take the reciprocal of the base. So if you have the reciprocal of x, it will be 1 over x. Notice that drops the base to the bottom and it will make your exponent positive. And this is summed up on the next slide. So to make a negative exponent positive, we're going to take a reciprocal, we're going to take the reciprocal of the base. That will force the x down to the bottom in this example, and it will also make your exponent positive. So the definition of negative exponents is summed up here. If you have an x raised to the negative n power, to make that negative n a positive n, you're going to take the reciprocal of x, which is 1 over x. Notice your n becomes positive. Let's look at the examples below. We have x to the negative 10th. Notice to make that exponent positive, that's kind of like an x over 1. So the reciprocal of x is 1 over x. That forces the x into the denominator and makes the exponent 10 positive. In the next example, we have 1 over a to the negative fifth. Notice to make that exponent positive, we're going to take the reciprocal of 1 over a, which is a over 1. That will make your exponent positive. So you would have a to the fifth over 1, which will equal a to the fifth. 2 to the negative third power, the reciprocal of 2 is 1 over 2. That makes your exponent positive. And then 2 cubed you can see is equal to 8. Now notice what it says at the bottom right here. To write b over a to the negative first with a positive exponent, we're going to take the reciprocal of the base. So the reciprocal of b over a would be a over b. And a to the first power is a, and b to the first power is b. So you would just have a over b. Let's practice some more to help you understand this. If I can get my pen to work properly. Bear with me while I'm trying to go to the next slide. It just does not want to cooperate. I can see it's letting me write. Maybe I'll write over to this. It's like my cursor is stuck right there. Oh, brother. There we go. Thank you for... Whoops, there we go. Great. Well, hopefully it'll keep working. So let's write these with a positive exponent and then we'll evaluate them. So if we have 5 to the negative second. The reciprocal of 5 will be 1 over 5. That makes your exponent positive. So we have 1 over 5 squared is 25. 3 to the negative third, the reciprocal is 3, is 1 over 3. That's forcing the 3 to the denominator, making our exponent positive. 3 cubed, 3 times 3 times 3 is 27. 1 over 8 to the negative second. The reciprocal of 1 over 8 is 8 over 1. That forces the 8 to the numerator, making your exponent positive. 8 squared is 64, but 64 over 1, we'll just write it as 64. 1 over 12 to the negative 1, the reciprocal of 1 over 12 is 12 over 1. Makes your exponent positive. So we have 12 over 1, which is equal to 12. And my pen is acting up again. All right. X to the negative second, the reciprocal of x is 1 over x, making my exponent positive. 1 over x squared. Y to the negative 10th, the reciprocal of y is 1 over y, pushing y to the bottom, to the denominator, making my exponent positive. The reciprocal of 1 over a is a over 1, making my exponent positive. I'll rewrite that as a to the 6th. The reciprocal of 1 over b in example h will be b over 1, pushing my b to the top and making the negative 4 exponent a positive 4. B to the 4th over 1 is just b to the 4th. And I'm stuck again. Maybe you can try the problems on the next page while I'm trying to get this to scroll forward. I really don't want to have to start over. How frustrating. Technology. There we go. Hopefully you're still with me. All right. Notice we have in I, once again, we're rewriting our expressions with positive exponents. We have 4 times x to the negative 7th. Now notice the 4 has a positive exponent of 1. It can stay right where it is. But the reciprocal of x is 1 over x. That forces the x to the bottom to make my exponent positive. The 4 remains in the numerator. Negative 6, y to the negative first. We're not trying to make the negative 6 into a positive 6. Remember, we're only trying to make negative exponents positive. There's a 1 on the negative 6, so it can remain in the numerator. We're trying to make the negative 1 exponent on the y positive. The reciprocal of y is 1 over y. That pushes y to the denominator, making the 1 a positive 1. But the 1 as an exponent is implied, so we can just leave our answer as negative 6 over y. In example K, once again, the negative 5 has a positive exponent of 1. It can stay right there. The reciprocal of 1 over b is b over 1. That forces the b to the top, making your exponent positive. Now, if you want to keep that negative with the 5, you can. You could also just pull it right out front and put negative b to the 8th over 5. The negative 3 is fine. It has a positive exponent of 1 right there. We're just going to bump the v to the top to the numerator to make my exponent positive. So I'll just have negative 3 v to the third. And all that would be remaining on the denominator is a 1, so we can just write our answer as this. So these are our answers here for this page. Rewriting with positive exponents. All right, the next slides just sum up all the energy exponent properties that we've learned so far. So the first one, remember that when we're multiplying with like bases, and I'm just going to look at the examples. If I have b squared times b to the fourth, we know that we add our exponents. B to the 2 plus 4 is b to the sixth. When you're dividing, b to the fifth divided by b squared, we subtract our exponents. B to the 5 minus 2 is b to the third. And that rule's right there again. The power rule for exponents. If you have b, and I'm just looking here, we just did that one. Let's look at this one right here. If you have b to the fourth raised to the second power, that's a power raised to a power. So we know we multiply our exponents. That would be b to the 4 times 2, which is b to the 8th. If you have a product within parentheses, a times b, and it's being raised to a power, each of those bases must be raised to the power. A is raised to the third power, and b is raised to the third power. And also note that if you have a fraction that's being raised to a power, whatever's in the numerator must be raised to that power, and whatever's in the denominator must also be raised to that power. So if you have a over b raised to the third power, that will equal a cubed divided by b cubed, or a cubed over b cubed. And then in this section, we know that if we have an expression raised to the 0 power, that's equal to 1. And we also know that if we have a base with a negative exponent, we can make that exponent positive by taking the reciprocal of the base. In this case, the reciprocal of b is 1 over b. Notice that makes your exponent positive. Alright, so we're going to be applying these exponent rules in the following problems. So notice in these examples we're dividing. We have like bases. Here we have y cubed divided by y to the 8th. And we know that when we're dividing we subtract our exponents, so this will equal y to the 3 minus 8, which equals y to the negative 5th. And now we need to rewrite our answer with positive exponents. The reciprocal of y is 1 over y. That forces y to the denominator, and it makes my exponent positive. I need to try to write a little bit smaller. I'm not going to fit all of this on here. Now notice we have a negative 12x divided by a negative 18x to the 6th. There's a 1 there. A negative over a negative is going to make my expression positive. Now 12/18 we can just simplify that. Let's divide each of those by the GCF, which is 6. 12 divided by 6 is 2. 18 divided by 6 is 3. So notice we have a 2 on the numerator, a 3 on the denominator. And we're doing x to the 1 minus 6. So that is 2x to the negative 5. over 3. So the 2 is fine where it is, the 3 is fine where it is. The reciprocal of x is 1 over x. That forces my x to my denominator to make the exponent on it positive. In my next example, I have x to the 7th, y to the 5th divided by x to the 9th, and that is a y to the 1st. So this will equal x to the 7 minus 9 and y to the 5 minus 1, which equals x to the negative 2, y to the 4th. Reciprocal of x is 1 over x. That forces my x to my denominator to make the exponent positive. The y to the 4th remains on the numerator, so we have y to the 4th over x squared. Two-fifths you can't reduce in example D. Once again, we're simplifying and we're writing our answers with positive exponents only. So we have a 2 here and a 5 here. I'm just going to write those down. We're dividing, so we're subtracting our exponents. I'm going to have m to the 6 minus 9 and n to the 2 minus 10. That's 2m to the negative 3, n to the negative 8. Now making our negative exponents positive, we'll only be left with the 2 on top. The 5 will stay where it is. Maybe it's not even going to let me write right now. Let me put my answer up here. So I'm going to have 2, 5. The m will come down to make my exponent positive. My n will come down to make my exponent positive. And I know there's a way for me to erase this, but I'll just cross that out. All right. Example E. I can reduce 14 sixteenths. I can divide those each by 2. 14 divided by 2 is 7. 16 divided by 2 is 8. And I'm dividing once again, so I'm going to subtract my exponents. So I have a 7. Hopefully I'll have room here. 7x to the 4 minus 3, y to the 5 minus 9, z to the 2 minus 1, all over 8. So this will equal 7 x to the 1st, y to the negative 4th, z to the 1st, over 8. Look for your negative exponents. It looks like the y, we need to take the reciprocal of y, which is 1 over y. That's forcing it to the bottom. So we will have 7xz, we don't need to put the 1's on the exponents, over 8y to the 4th. Looks like we have 6 more examples. And there's a lot to write, so hopefully I can fit it all on these slides. I'll try to write a little bit smaller. All right, so everything inside these parentheses in f has to be raised to the second power. And we're using our power rule for exponents. So recall, when we have a power raised to a power, we're going to multiply our exponents. So we're going to have negative 3 raised to the second. We're going to have x to the negative 1 raised to the second. And we're going to have y to the negative 2 raised to the second. So negative 3 raised to the second power is positive 9. We're going to have 9. X to the negative 1 times 2 is negative 2. Y to the negative 2 times 2 is negative 4. And now all we have to do is make our negative exponents positive. The 9 can stay in the numerator. The reciprocal of x is 1 over x. That's forcing the x to the denominator to make my exponent positive. And the reciprocal of y is 1 over y. The y is coming down to make my exponent positive. So we'll have 9 over x squared y to the 4th. G, everything within the parentheses is being raised to the negative 3rd. So we have a 5 raised to the negative 3rd. Just wait a second to simplify that. we have x squared raised to the negative third, and we have y to the negative third raised to the negative third. So that's a 5 raised to the negative third. X to the 2 times negative 3 is negative 6, and y to the negative 3 times negative 3 makes it a positive 9. Look at your exponents. The y to the ninth can stay on the numerator. The 5 raised to the negative 3 has to move down to make my exponent positive, and the x is being forced to the denominator to make the exponent positive. Now we can simplify the 5 raised to the third power. So we're going to get y to the ninth. 5 cubed is 125, x to the sixth. Negative 2ab to the negative third multiplied by 4a to the negative 2b raised to the negative second. So notice everything in here is being raised to the negative second. So we have to do that first, and I'll try to write small. So we have a 4 being raised to the negative second, a to the negative 2 being raised to the negative second, and b1 being raised to the negative second. So that's going to be 4 to the negative second. A to the negative 2 times negative 2 makes it a positive 4, and 1 times negative 2 for the b makes it a b to the negative 2. And so we need to multiply all of that by negative 2ab to the negative 3. Alright, so now let's look for like bases. This is an a to the first. Okay, so we're going to have a negative 2. We have an a to the first times a to the fourth. We have a b to the negative third times b to the negative second. And then recall that we also have the 4 raised to the negative 2. Okay, don't simplify that yet. Alright, so this gives us negative 2a to the 1 plus 4 is 5. b, negative 3 plus negative 2 is negative 5. And then we have that 4 to the negative 2. I don't like the way I'm writing that there, but you'll see what I'm doing. Anything that has a negative exponent is going to be forced to the bottom to make the exponent positive. So I have negative 2a to the fifth over 4 squared. It's being forced down. The reciprocal of 4 is 1 over 4. It's forcing it to the bottom, and the b is also coming down to make my exponent positive. So I have negative 2a to the fifth. 4 times 4 is 16b to the fifth. And now I need to reduce my fraction to 16. I can divide each of those by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. And then on the numerator, 1 times a to the fifth is just a to the fifth. So I get negative a to the fifth over 8b to the fifth. I hope you've been able to follow that one. Usually if I have a constant being raised to a negative power, I wait till the very end to simplify that because it's going to have to move if it has a negative exponent to make it positive. Alright, I believe we have 3 more examples. And my screen is twirling. So I'm just going to have to wait a second and hopefully I don't lose what I've done so far. Alright, hopefully you're still there. We'll see how this video turns out. So I have a to the negative third b to the negative fourth divided by a squared b squared. So we're dividing, so we're going to subtract our exponents. I have a to the negative 3 minus 2, b to the negative 4 minus 2. That will equal a to the negative fifth, b to the negative 6. I will need to take the reciprocal of both of those to make my exponent positive. The reciprocal of a is 1 over a. The reciprocal of b is 1 over b. That's forcing the a to the bottom to make the exponent positive, as well as the b. Now notice in j I can reduce 3, 6. 3 divided by 3 is 1. 6 divided by 3 is 2. On my numerator, there's a 1 here. I have x to the negative 2 minus 1 and y to the 2 minus 2. Still have a 2 on the bottom. That will give me x to the negative 3 and y to the 0 over 2. Recall that anything raised to the 0 power is equal to 1, and x to the negative third times 1 is just x to the negative third. The reciprocal of x is 1 over x. That will take my x to 1 over x. That takes my x to the bottom to make my exponent positive. So I have 1 over 2x cubed. Alright, and this will be our final problem, except for the u tries. So everything in the numerator is going to have to be raised to the negative third power. So let's see what this is going to look like. Hopefully it won't write out too messy. So we have 3 to the negative 1 being raised to the negative third. We have x cubed being raised to the negative third. I have y squared being raised to the negative third. And I have z to the negative 2 being raised to the negative third. And then on my denominator, everything inside these parentheses is being raised to the negative second. So I have x to the negative 2 being raised to the negative second, y to the negative 3 being raised to the negative second, and z squared being raised to the negative second. I feel like I'm talking in a monotone. Alright, let's simplify this and put it right over here. So looking at your numerator, we have powers raised to powers in all of these, so we're multiplying our exponents. So we have 3 to the negative 1 times negative 3. That's going to be 3 to the positive 3. We're going to have x to the 3 times negative 3, which is x to the negative 9. We're going to have y to the 2 times negative 3, which is negative 6. And we're going to have z to the negative 2 times negative 3, which is positive 6. On the bottom, x to the negative 2 times negative 2 is x to the positive 4. We're going to have y to the negative 3 times negative 2, which is positive 6. And we're going to have z to the z squared raised to the negative second is z to the negative 4. So now we're dividing, and when we have like bases and we're dividing, we can subtract our exponents. We'll go ahead and simplify the 3 to the third power. That's 27. And then I'm going to have x to the negative 9 minus 4, y to the negative 6 minus 6, and z to the 6. Now be careful here, it's z to the 6 minus negative 4. When you have minus a negative, it's going to make that positive. So we have 27 x to the negative 13. We're adding our exponents here. Y to the negative 6 and negative 6 is negative 12, and z to the positive 10. We're almost done here, so now we just need to make negative exponents positive. The 27 and the z to the 10th will remain in the numerator. Taking the reciprocal of the x term and the y term forces that to the bottom, so that will be x to the 13th on the denominator and y to the 12th.